every single video you make, every single thing I talk right now, if you record it, put it online, ultimately, it will be crawled into the big database to train the ChatGPT.
Yeah.
We are never going to be outside of the experiment to observe it. We are already inside of the experiment. So I really enjoy today's conversation, Jay.
Yeah.
I think we should make some kind of agreement. In 24 years, let's do another podcast.
Yeah, yeah.
And I think in 24 years, we will see a generation of people that had basic education about AI starting from elementary school.
Yeah.
At that time, we may be able to see what the influence of all this effort we are doing that actually impact the society, and the society impact AI development as well.
True. All right. So hello and welcome everyone to whoever is listening to this particular podcast. Today I have with me Professor Yezhou Yang from Arizona State University. Dr. Yezhou Yang is an associate professor at Arizona State University and the director of Active Perception Group at ASU. He has research interests in cognitive robotics and computer vision and understanding human actions from visual input and grounding them by natural language. Prior to joining ASU, he completed his PhD from University of Maryland and his postdoctoral from Computer Vision Lab and Perception and Robotics Lab. It's nice to have you, Professor, on the podcast.
Oh, thank you, Jay. You can call me YZ.
Okay, YZ. Okay. So let us start from the very basic. That what was your entry point in AI, and when did you understand you liked AI, and how did you consider doing and pursuing research as a long-term career?
This is a great question. I think the earliest memory that I had with AI is, I don't know whether when you were super young, like 6, 7, or in your elementary school, whether your parents bought you at that time, we don't have internet, we have anthropology kind of book, right? So something like a Wikipedia in a book.
Okay.
And I still recall one item entry is artificial intelligence, small paragraph talking about artificial intelligence. I cannot recall clearly what it describes. Basically, a machine that can help human beings automate things like that. So I think that's the earliest in my life get into the term artificial intelligence, of course in Mandarin at that time. And then I started to join college. I went to Zhejiang University, which is just across the street of my home, because it's closer. So I decided to go there. At the very beginning, I don't know what major I should pursue, like many first-year undergraduate students. So we have this program that basically go with the basic engineering training for the first 2 years. And then during the first 2 years, I got into the class, which I'm teaching here in ASU, which is a course that I truly enjoy teaching, is data structure and algorithms. Okay. I can still recall the teacher, the professor teaching that. She actually got a PhD degree from University of Delaware. Okay. And then he went back to China and teaching the course fully in English, actually. It's a very fancy thing. She taught that so well that I got fascinated with data structure and algorithms. And we have a course project. At that time, I think I basically developed a very basic kind of chess game. Yeah. And then you can use, I still recall, a few rules to implement a very basic AI. You can play with it. It's points-based, right? Yeah, so every single move, you have a points, you sum them up, you decide which the optimal move to do. So that was the time I got truly, hooked up with computer science, and later on in AI. So in my second year in college, I got introduced into a team. At that time, I don't know whether you've heard about a competition called Robotics.
Oh, yeah, I've heard that. Yeah, it's a popular one.
Yeah, so actually we were working with, as undergraduate students, I was working with a group of graduate students at that time from the Control College. And we were competing in the worldwide Robotics. Yeah. So I can still recall in my third year, we visit grass to compete in the World Championship of RoboCup.
Wow.
The team name, I think, is still popular in that circle.
Yes.
We call it Zoo Dancer. If you mention Zoo Dancer, many people might still recall.
True, I've heard that. Yeah.
And that's basically we design our own humanoids and play soccer against each other. There are all the video shots still lingering online. If you search on YouTube, there's still Zoo Dancer, ZGU Dancer with other teams. We got 8th place, like 8th place at that time. And my role is developing the goalkeeper.
Okay. Yeah.
So there are some nice shots on the internet still there. We have our goalkeeper. Our forward and striker are not that good.
Yeah.
So our goalkeeper are keeping rejecting the balls away. So that was the first time I got introduced to computer vision, right? So we use a single camera, to estimate the speed of the ball, which is the orange ball.
Yeah.
I still recall the algorithm we developed at that time. I think I wrote every single bit of it. Is called pixel filling or something like that, which was introduced by CMU. Tracing back to 90s. Right? Okay. So we were developing that algorithm. It's running super fast. It can trace the ball well, and it can basically reject the balls. And also around that time, I got introduced into the cognitive vision lab over there in my college. We started to do a research project under this topic. I don't know many of you guys. You must have heard about attention because all the transformers and all the current trend. But at that time, around 2009, 2008, there is a whole topic called visual attention.
Okay.
So basically, the challenge is apparently our vision faculty are not processing every single bit of pixels, right? Otherwise, it's like over demanding to our computing faculty. Yeah. So the challenge is taking in an image and have algorithm to figure out which part of the image is important to put your gaze on, right? To focus on, like just like human beings, we're gazing here, like when I'm having a conversation, my gaze is actively moving around. And the interesting part of it is, unless you really open your skull and put sensors into your brain, the most direct signal you can capture to see through human being is to following their gaze. Because this is information that is telling a lot of the underlying cognitive process. Actually, NLP people, natural language people doing that a lot. When you are reading a piece of text, right, which word you are currently processing and the kind of the cadence of reading that piece of word text, following your gaze, tells a lot of the underlying processing of your computation, right? So gaze is an interesting thing. At that time, there was the first big data set introduced by MIT. I think I still can recall this paper from ICCV. I shared it on my Twitter recently because I recall that's the first ICCV paper I read that has 0 equations in it. So it introduced a super nice data set. It's got very popular. It's called Learn to where to look, like learn to figure out where to look.
I see.
And we use that data set. We'll introduce some, I was undergrads, so-called chance of happening based modeling to predict from a given any kind of images where to look at. That got published in ECCV 2010.
Okay.
So the interesting thing is when I get to UMD, the first meeting I had with Yannis Alimonas, which at that time was my advisor, I showed him the paper. He told me that I'm aware of this paper. So that was the entry point I get into a more serious computer vision training and AI training. So I spent 6 fabulous years at UMD College Park. I met my wife over there. We moved to Arizona here together, and now we have two young daughters. Ever since after we joined Arizona. So I would say the whole journey with AI, starting looking back until now, I'm very happy with my the early encountering with AI and all the way to know all the great people and have good conversations and hold a learning curve to this point.
Yeah. And I think the nicest thing I find from that story is like you got started and interested in vision before the whole era of convolution neural networks came into
Yes.
place. So
Yeah.
you have much more of a rigorous love towards vision than most of us like young students have, because I think we got interested because of the fantastic results we get from convolution neural networks, and I think I got started pretty much late. So it's like already great developments have been done, amazing things like how CNNs operate. It was black box to a lot of people, it still is, but you got started from the very structured way of getting into vision.
You can put it in this way, but I would say it's also it's a bit of exaggeration.
Okay.
Because the time I got introduced into computer vision, that was early, late 2000, right? So 2006 to 2007. At that time, ImageNet and classification-based algorithms already dominating the field.
True.
So if you want to look back a bit, all the way back to the 1980s, 1990s, that was the time geometry was dominating the field.
Yeah.
1987 is the first year ICCV being organized. Okay. Happens to be the year that I was born. Okay. But anyway, a lot of stories I had with Yannis Alimonos, and also his senior colleague, Rosenfeld, was considered one of the founder in computer vision field. We talk a lot about old days geometry-based processing, how people basically deal with all the geometry constraints that you can come up with to constrain the visual processing. Classification and machine learning got introduced into the field. The general consensus is ever started from Cartech 101, all this data set, and then cognition as a classification task being the popular trend in the field. I think is still the topic till now.
Yeah.
I teach perception robotics in ASU. Of course, many of you guys may ask, like, why would you still teach things like stereo vision, right? Optical flow? But if you go back and read some of these classic papers, for example, what's the Lucas Canaday methodology? If you have heard of optical flow, Lucas Canaday. Okay. Canaday is the famous name in robotics back in CMU. A lot of the technologies, such as pyramid filtering, such as coerce to fine processing, you find the feelings of current architectures, their roots in those algorithms. So a lot of these techniques are being reused, like circle by circle. Yeah. So not everything is new. Yeah. But the good thing about knowing the history is the ultimate equalizer. so you can find a good trace to where this kind of ideas being started. And I don't think anyone should be able to claim any idea nowadays would be 100% new, unless this is super. Human civilization has lasted for how many years, and arguing any ideas to be new is too much. Yeah. I would think reinventing and modernizing old ideas is the way that the kind of research we are doing as well. That's also the principle guiding our research at ASU as well.
True. I mean, even like it was not very earlier ago that I found out like how the backbone of CNNs were existing previously for many years, and it was just like a combination of a lot of stuff, like the whole ImageNet challenge came in, how the hardware acceleration came into place, how the effective implementation of CNNs came, and hence there was like this whole big burst of around CNNs using images. So it's more like I would say research building on top of other good researchers, and completely, it's not like if you invent a new paradigm, then it's a different thing.
Totally agree.
It's building on good blocks.
Everyone is standing on the shoulder of the giants.
Yeah,
right?
Sure.
but one thing I want to point out is rigorous training in geometry as well in fundamental vision problems gives you a set of weapons.
Yeah.
That when you encounter a new problem dealing with vision, dealing with the real world practitioner challenges, you can go back to maybe scan through all the set of weapons you learned from the rigorous training, and many of them are still being reused nowadays in industrial practices, right? So just like why you learn physics in high school, are you going to reuse all this physics knowledge, right? It gives you a way of thinking. And also the most important thing is when you get into difficulties, get into challenges, the way you set up your mind, how to address them.
Yeah.
Right. So it's critical. I think it's critical.
And I think most of the sciences, like including AI, is much more interdisciplinary, right? So like you learn from a lot of other sciences being developing their works or developing their algorithms. So like it's more like how I can learn from other sciences, even if it's like medical sciences, if it's like physics, like you said, a lot of things. Like I think one of our lab mates who is like currently applying for jobs, I learned how they are using physics-based AI-based physics simulations to understand Navier-Stokes equation. So it's like completely new, and like his interviews are much more aligned towards like the physics side of it. So it's like how these two fields are combining to solve a bigger problem.
This aligns well with the fundamental challenge in AI as well. Human beings are so good. I mean, we are so good at making analogies. We're so good at transferring from one domain to another domain that basically looking at how physics people doing addressing this task in this way. Can I similarly map to a new challenge and make innovations? I think it's still challenging for current AI to deal with that.
True. And talking about, I think a lot of things, like I would relate to this next question to how we as students nowadays feel about AI is there are lots and lots of developments in AI, and all of the fields feel very fascinating, like developments of AI in, let's say, robotics, in vision, language, reinforcement learning, a lot of other stuff. And we normally tend to find it very tough to find like what exactly to work on, because all of them seem very interesting to work on. So I want to understand, how did you land up? So you said like when you came to UMD, you started working on perception, and that's where your backbone of like a person or an expert in perception came along, and that's what you have been doing at ASU. So how did you find out? So like you had a very basic understanding of vision, a very like basic interest in vision. How did that develop into perception, or basically you had no other options? Like I don't know.
I think a lot of random things happens. That's why I consider myself really fortunate. So in the time 2010. I joined ASU. UMD. Famous. I think you must know his name, Hao Dongmei, doing NLP, natural language processing. He joined UMD from Utah that year as well. So he started the NLP course. And I was his first batch of students taking his NLP course. And during the course, there's a course project. So I was discussing with my teammate, I would do vision, right? There's all the language modeling, language parsing. At that time, he was introducing all this IBM model 4, just 4 terms, and you start to model statistics. It can generate some kind of, gibberish generated language, not as fluent as nowadays language model can do. But we were basically saying, hey, can we use this language modeling to further regularize the object recognition, recognize the things, recognize the activities from images? So that leads to my first published paper in graduate school called I cannot really recall the exact title. It's basically doing something like image captioning. So we propose taking an image, and then you have a language model, very rudimentary language model, to guide the recognition of the image. At that time, you apply object recognition, apply scene recognition, apply action recognition to link them together to output a sentence.
Yeah.
That was 2011 EMNOP. Around that time, a few other groups also proposed similar tasks. But I still believe we are one of the first proposing image captioning that leads to the neural way of modeling image captioning in 2015 that really goes up. The image captioning field got noticed. And that leads to all the image text alignment learning that leads to the large multimedia models. So I would consider myself very fortunate at that time. And my advisor at that time, Yanis, has a project called Robots Needs Language. That was 2006, right?
Wow.
Robots Needs Language. That was his vision. And we were using language models. NLP folks haven't got into too far at that time, so we want to leverage too much from the language to help vision. But nowadays, it's getting together.
Wow. I didn't know. Like, I think the intersection of language and vision, I didn't know it went this much back into the history. Like, I always thought it was in the last 4 or 5 years.
So my advisor, Yanis Alimodas, has multiple rounds of European projects called Poeticon. And that project is basically dealing with this term, robots needs language, how to use knowledge graphs, how to use language modeling to improve robot perception. So that was the days language got introduced into computer vision and perception.
I see. Interesting. Yeah, this is something I always like about, I think, reading the old books. It's like a lot of stuff has been done, but maybe for some reason it did not surface to a lot of people, or it did not get developed further. But I think it has like some fantastic contributions that can be leveraged in the future.
Yes, and that reminds me, I was preparing a talk recently, like if you were following, well, I was giving a talk at the department, and I was trying to figure out like what's the origin, where is the origin of using knowledge graph or dynamic knowledge for assisting visual recognition. I came to a paper that was published in 1970. It's actually a master thesis from an MIT student. It's doing, at that time, pixel level images. At that time, if you got a digital image, you need to travel to some university has a digital scanner to scan a digital image.
Oh, right.
He scanned a digital image of hammer, and used that as the only input to show that recognizing it is as a hammer, you need to recognize the handle, recognize the head, and handle and head putting together is the hammer, right? So like it goes back to my argument. And by the way, that master thesis only got cited 27 times. Like what you are saying, like it's not being noticed. Hopefully, after I give my talk, more people start noticing his thesis. True. And I don't know where is this author right now. Say hi to you right now. I mean, and that was like 100-page thesis talking about how to use dynamic knowledge to facilitate visual recognition system. I can share the link with you if you want to put it under your
we'll be putting them
YouTube.
in show notes. But like this, I mean, we'll come to the next question. But I think one question I wanted to learn is like there's this whole shift. I wouldn't say shift, but a change in robotics or in general AI is like when we have semantic knowledge or knowledge-based graphs. Or I think when I was talking to Professor Rao, he works on the symbolic AI stuff where like you have to hard code rules and there's a little bit of learning. Versus nowadays when we are seeing like end-to-end based learning models where you have unstructured data most of the times, and AI models are trying to learn patterns or rules by itself. How do you see these two fields being like? Are there any pros and cons of like using knowledge-based graphs versus end-to-end? Like, are there any limitations for both of them, or end-to-end learning has gotten so much better that we can scrap off knowledge-based or like rule-based AI?
This is a great question. It's also a tricky one, right? So if you go back to the first textbook of AI, AI is defined as the following task, right? It's just enabling an intelligent agent, being able to perceiving the surrounding world, computer vision, and optimize its actions to achieve the goal, right? To optimize its chance to achieve the goal and whichever the goal is being defined. So I think the challenge here nowadays is purely text and image large data alignment learning is lacking of a specific goal, right? So what is the goal of ChatGPT? If you were asking me, I cannot. I mean, making the user happy, or like what is the target you would like to optimizing towards?
Right.
On the other side, symbolic modeling and formal methods, people always start from a goal, right? So what is the ultimate target you want your agent to be able to do, right? And then derive all the steps, all the plans, all the intermediate, you can call it reasoning, you can call it optimization to achieve this goal. So if you were asking me 2 years ago or 1 year ago, I would say we need both. But with the witnessing of all the amazing performance LLM and LMMs recently coming out, I'm not so confident. So I will put a question mark there. One of the argument I had a discussion with a professor at CVPR this year. His point is basically the GPT and all the large language model, large foundational models is showing an alternative way to achieve intelligence. So a typical way that we follow is we follow the evolution steps, right? So we start from vision. So like being like very fundamental. You see ants have some vision as well. You see insects have some vision as well. They can navigate, right? Then it's building it up, right? So now later you evolve into natural language capabilities. And maybe the natural language capability has some similar structures because of you need to do vision well. That's being shared to create the natural language understanding, and then you achieve being able to reason, being able to analyze, and being able to achieve, maybe enlightenment or intelligence. But all the experimental results that we see from LLMs seems to be suggesting there is an alternative way. This alternative way is collecting all the digital presence of human beings, human civilizations, and use self-supervised learning paradigms to create alignment within it, and it bypassed the whole evolutionary tree, right? So all the steps they go by bypassing it, and then he goes to this whole argument that apparently achieving intelligence as we did, as human did, may not be the only unique way, right? If you think about, there might be other planets developing intelligence as well. So if that's not the only way, we should be open to other possible alternating ways to achieve intelligence, like what ChatGPT is trying to show as well. Of course, a huge question mark here. No one knows.
So it would be basically impossible for us to validate if the intellectual, I don't know if reasoning is the right word, or the intellectual knowledge that it has learned is purely by memorizing or learning the wrong patterns, but it could be the thing that it is learning something patterns that we are not able to comprehend.
As Rao pointed out, right? So he has a blog talking about it's a super sophisticated retrieval mechanism, right? So it could be, but this is equivalent to one of the challenges we're dealing with, like how to evaluate whether the model essentially grasped the concepts that you want it to grasp, right? Just like you have high school students knocking on your door and, hey, Professor Yang, I want to do deep learning. And you start to ask him some questions like, oh, deep learning, what do you know about deep learning? Like, what do you know about transformers? What do you know about? And he'll tell you something, right? And the challenge here is, how can you tell whether he or she actually grasp these concepts, actually grasp the underlying connections behind all the verbal presentations one can develop, right? That leads to some of our recent work, Matria and Agnit, and also Tijas and Shenton, my recent PhD student trying to do is how to create rigorous benchmarking or testing mechanisms to test whether LLMs or generative AI tools such as Stable Diffusion actually understand those concepts, right?
Yeah.
So I would recommend to read our concept-based paper, which is on ICAF right now.
But it's very interesting how we are trying to move our AI field. Normally, like in most of the engineering stuff, we try to build step by step, right? Like we try to build the smallest blocks first, and a complex version of that is like a combination of those blocks, and so on and so forth. But now if we see the AI research, we have this big tool that can do a lot of stuff, and we are now trying to diverge our way back from the top, trying to understand if it is doing so. Like now we are building benchmarking to understand if at all LLMs, like we don't know how and why LLMs perform so good, but we are trying to develop other techniques to understand if at all it is working good or not. Is that fascinating to you? Because like in the previous time, like you said before, I think 2012, you were trying to build something like a very from scratch, like you have knowledge graphs and all those stuff. Do you feel this as a hesitancy towards these kind of AI shift, like a shift in how we conduct science in general?
Yes. I mean, this is a very deep question, right? So, my point that's it to the especially students that are getting into AI is this is exactly the point you should get motivational. Well, that's exactly the point that we are getting at this exciting era to do AI. It is the separation, just like many of the physics development and other development before, it was in labs, right? So controlled labs. Now it is being deployed all over the human society. So this is actually the ultimate thing that motivates me to continue doing AI is such a fascinating platform. It's essentially is a large scale. It's not large scale. It's gigantic scale, societal economical experiment. At this point, I want like to tribute to one of the famous researcher, Fei Li. You know him, right? ImageNet. I think like in his CarTech 101 data set, if you go to the human category, he put her own faces under the data, right? So in the data, I think if you download CarTech 101, you can still be able to check how Fei looked like when she was in graduate school, and also her advisor. This is, to me, I think it's a performance artist kind of act. At that time, they are already realizing we are in the experiment. We are not out of the experiment. Now, every single person is in this experiment. Every single thing you say, you put on the digital world, we're going to be chimed into ChatGPT to the next version. Every single video you make, every single thing I talk right now, if you record it, put it online, ultimately it will be crawled into the big database to train the ChatGPT. We are never going to be outside of the experiment to observe it. We are already inside of the experiment. So this whole paradigm of understanding how AI works, how AI going to influence the society, how the society will influence back to AI, we need to have a totally new paradigm to test and test our hypothesis. If we are standing out of the system, everything you observe, you can control. A lot of the experiments can be designed in such a way. Most of the previous versions of AI development is following such a paradigm. Now we are, each of us, every single thing you put up is already inside of this experiment. And the challenge is truly is we are inside the experiment, but we want to still being able to understand and explore what's happening surrounding us.
Yeah,
Right. That's the fascinating part.
Yeah, it's like hard to get the global picture when you're part of the whole
Exactly.
picture itself.
It's
So
like this whole all the philosophical debate, right? So now if you have you ever seen a figure that you have left hand drawing the right hand?
oh yeah.
Because you are within the system.
Yeah,
It's difficult for you to within the
True.
system to understand the system itself.
yeah,
And that's the challenge.
yeah.
And that's the fascinating thing. Now and if you are talking to many of the technology workers or research scientists in big firms like Google, DeepMind, I wouldn't be surprised most of the people hold such a belief. We are in a huge, gigantic societal economical experiment, and that's the exciting thing, right? No, it's not possible in old days. Now it's possible. Now we are launching this experiment, and we need platforms, we need benchmarks, we need ways to pick into it.
Yeah.
We need ways to control it. We need to control this essentially a dynamic system that models updating, humans updating, human updating, models updating, ever growing and changing dynamic system. That's the fascinating part.
And one of the things that you did mention is like trying to understand the broader goal. It's sometimes missing in most of these AI systems. Like you said, like what is ChatGPT trained to basically do? It's it's basically like the overall goal is kind of confusing. So let me ask you this question in a very like 5-year-old kid kind of way. So you're working on building cognitive AI, or basically cognition in AI systems. Why vision and language? Like, what is the hypothesis behind using these two? I don't know if modality is the right word, but like using these two things. What is the relationship to human cognition, and how does it affect building cognitive AI?
Well, I mean, there's a practical answer to it. There's also a theoretical answer to it. I think the practical answer to it is this era that we are living in. Image and text are still the two dominant modalities. Right. So if you believe there is an alternative way to achieve intelligence, then the vast amount of images and videos and also text data that is being available, that's the playground. That's the data we have, right? You never record, or you rarely record things like action plan, and then you upload it on internet, right? So the amount of data is really limited. That's why robotics is hard, right? You hardly basically record all your positions of your movement and upload it online, right? So to serve as the training data. So the practical reason is the data is there. The theoretical reason, I think, all these fields are imagined terms, right? You could say, oh, hey, you do vision, hey, you do NLP. Ultimately, what we are doing is essentially trying to figure out optimization way to maximize the agent's chance of achieving its goals. So the overarching goal is the same, whether you are doing vision, NLP, robotics, or other AI fields. Ultimate goal is still very similar. When you say, hey, whether it's vision or language, more or less it's just different groups of people. But I don't see the boundary is very clear. It's very blurred. And also nowadays, vision, language, and planning, right? Vision, language, and robotics, there's almost no boundaries stand there anymore.
Yeah. And do you think moving forward it's gonna be like much more merging between these different fields? But I decided on asking this question much earlier, but now you mentioned like this was being done since 2006 by your advisor. So I don't know.
No, I'm not claiming he started it, but there's a lot of early thinkers doing that, right?
But would you say that we would be seeing much more merging between different modalities of AI that have been historically doing standalone research, but we'll be seeing like much more merging of like how clip model that came out, it is trying to merge these two latent representations of the same thing but in different modalities, and it outperforms in some ways. And how we are seeing like the results are from ChatGPT. Like I think one of the recent reviews that came out from LLMs, LMMs from Microsoft, that they have like I think a 200-page report or something like that. And I saw the results, and like they're fascinating. Like some of the times I just feel like, okay, like what's more to do, that kind of stuff. So do you think moving forward it's going to be merging between different modalities and having more and more data, big and big models, that's the way forward?
It's a combination of multiple routes, right? So AI is a huge ecosystem. And you need foundational models. You need teams to train larger and larger foundational models. You also need teams to come up with crispy constraints, right? Either semantic constraints or geometrical constraints to further regularize those model training. Then you also need teams to do rigorous evaluation of them, right? So every single person has its specific role. You also need people to educating next generation of people, right? So otherwise it won't sustain. And as a large ecosystem, it's hard to say which pathway will ultimately be the pathway, right? So all the pathways are going, and that's the fascinating part about AI. It's a very diverse field. You can still go and talk to people. There might be still groups doing SVMs. They preserve, right? There's good things about that. And they are very practical and doing things well, right? So as long as it's diverse, as long as multiple schools of people can speak, can interact, can communicate, I would think we wouldn't be constrained by a single route of development or not, or maybe like you are mentioning, larger models. That's fascinating. That's one way to do it, and we all admit that, right? But there's also alternative ways, and we still need efforts to explore them as well. That's my view about why, and that's also why, at the very beginning, I was encouraging students to further pursue career in AI. It's just very diverse. You can even, not like physics, like chemistry. Nowadays, most of the problem statements are well set. This is the problem statement. AI is still at its early stage. That a huge amount of problem statements are not being proposed. You can come up with your own problem statement. That's the most beautiful thing of doing science. Right? You have a good problem statement, you basically finish 99% of your PhD degree. The remaining 1% is collecting data and conduct experiments. Right. So that's why AI is still a fascinating field to pursue academic career or researcher career.
And looking from a bird's angle view, like, do you find more commonalities between standalone vision research and standalone language research? Or like, I would say for you it's like much more merged between these two modalities, but like, how do you see these two fields? Like, are there more commonalities? Like, for example, tasks like domain adaptation, generalization, I think these are like more common to any kind of fields that is specific within the AI umbrella. So do you see more commonalities, or they are much more distinct in their own ways?
That comes back to the point that human beings, like researchers, are human beings. Like, human beings are really good at making analogies. So I wouldn't be surprised that any breakthroughs in any one single field, another group of people from the different field will find some insight and apply to the other field. For example, there is already discussion about training LLMs to do autonomous driving. Right.
Okay. I didn't know.
Right. I mean, well, and again, this is an interesting effect, right? So now everyone is so fascinated with language, right? Now all the applications is, I want a natural language interface. You want your natural language interface to talk to your autonomous vehicles. But what is the most ancient autonomous vehicle? like what is the most old style autonomous vehicle? Do you know?
Like bullock cart or something like that.
Horses.
Oh yeah, horses. Yeah.
Yeah, they never bump into each other.
Yeah.
They do local motions really well.
Yeah.
You know, you're riding horses, and then there's all these efforts. If you want to be able to master your own horse, you need to talk to it.
Yeah.
Right. You need to create emotional bonding. Right. Create connections, and then your horse that is listening to you.
True.
And we spent 400-500 years to get rid of that. Right now, you have a steering wheel,
Yeah.
giving out clear instructions to where to go.
Yeah.
And now we want it back to have the AV to listen to human drivers. And you may want to talk to your AV for like during off times to prepare your AV to understand you better. A lot of things.
Yeah.
It's fascinating, right?
Yeah.
But coming back to your question, I wouldn't be surprised that people will start to merge and finding connections and creating new promise statement that sponsor and initiate next round of development.
I see. Yeah. And one of the next questions that I have seen, like I have followed your research for a long time, and correct me if I'm wrong, is I want to understand, like you have been working on a lot of algorithmic based reasoning. So you want to create techniques that can reason a particular algorithm's learning ability. And I want to understand this from a very broad perspective. What is the difference between learning and reasoning? Because we clearly understand neural networks can learn. It's a different question how much good they learn, bad they learn, but they have the ability to learn. But we have seen neural networks cannot reason. So like it has like taken a little bit amount of time to develop sophisticated techniques on top of neural networks that can help us reason those patterns. So can you first of all help people understand what is the difference between learning and reasoning, and what makes neural networks inherently less reasonable in the past?
I think the learning and reasoning are two phases, right? Learning is from the observation from your surrounding environment. You get sensory input or data, right, and ground them into knowledge pieces. For example, if you are seeing all the vehicles with four wheels, majority of them, then you create a knowledge piece. Vehicles typically has 4 wheels. So this is learning, right? This is like you were being able to conclude some abstract terms or formulations or equations from vast amount of data. And reasoning is take those knowledge pieces and to do deductive, inductive logic to build upon them to create further things. So we call it, in my group, we call it reason beyond appearances. Your appearance tells you one thing, all the basic components. Then you use reasoning to infer and predict what is happening behind. Yeah. For example, one of the example in VQA is you have a stadium of 2 people playing basketball. And the question is, are there any audiences? Right? So 2 people playing basketball, there's no audiences from appearance. Of course, if you are saying it's a fierce game, the prediction is there will be audiences, just not being taken into this current view, right? So learning is ground them, what looks like a basketball, what looks like a player. Now you got into all the predicates. A basketball is being played with 2 players. They are wearing 2 different color of jerseys, so it's a game. Then reasoning is relying on these facts as well as your background knowledge to infer most likely there are audiences there as well. And this is also why it's challenging nowadays to evaluate large language models and generative AI models, because what we are basically saying is we are querying those models and they are outputting things could be seemingly showing they are doing reasoning, right? But since you cannot peek into the every single step leads to the reason to output, could be purely by chance, could be purely a pattern matching.
Right.
And then you got the most matched pattern out. That was the output that makes you believe it's doing reasoning.
Right.
It's just like there's a task called habitat, right? So habitat is a task basically you're asking your robot to question, like find a red mark. And the robot go and explore the space and then find the red mark and coming back say there is a red mark, right? How about if the language parsing of the robots is basically broken? Finding the red mark, it understand finding the blue mark, right? And then the navigation is also broken. He find a yellow mark. And the recognition is also broken. It's recognized the yellow mark as the blue mark.
Yeah.
And then the answer leads to yes. He comes back, tells you yes. Match the ground truth, right?
Yeah.
But can you tell whether it actually follows every single logical step to achieve this ultimate answer? We are not sure, and that inspires the whole paradigm how to formally test those systems, how to formally align the performance with human expectations and human intelligence. That's fascinating.
Yeah, and would you say like using something at the intersection of vision and language helps us reason better, or maybe develop techniques that can reason better, or is it not respective to any merging of modalities?
It ultimately leads to the amount of data that we can access, right? So I think every single image tells 1,000 words, right?
Yeah.
So if you can parse images well, it basically enlarge the language data you have, right? If you are parsing all the images with vehicles on the roads, and you are parsing, like say, red vehicles are typically over speeding, that gives you some kind of knowledge that can be further used in large language models as well. So vision provides images, or video data provides another modality of resources to train the large models, and adding on all the language data already existing. So it's from a practical perspective, it basically doubles or maybe triples or maybe 100 times more enlarged the text data by considering image in it. That's why that's my speculation why LMMs is performing so amazingly from the recent report from Microsoft.
True. I think it leverages few informations of how these categories or data instances are being understood, and I think it really helps, and it's going to be very helpful in trying to make applications that are much more robust. So because I think in one of the biggest problems in deep learning or end-to-end based learning is the confidence of models, right? It's very hard to judge. I mean, there are techniques where you can make them question and understand how much sure the model is, but I think adding an additional modality not only further improves the performance but the confidence of these models.
Right.
So the latent representation of like what exactly cat is, it's not just a random bunch of pixels being oriented with some specific channels and intensity values, but like this is actually a cat and what it means in its surroundings. So like cat sitting in the garden versus cat jumping on a river, like it understands those concepts better.
And your insight is probably right.
Yeah.
I think. And another thing, I mean, coming back to why vision and language is also this whole effort of doing AI, right? Ultimately, you need to bring AI to the general public.
Yeah.
And vision and language is the most direct modalities you can talk to the general public. So if you have multiple options, that which one you would like to use to create a presentation to the general public, to have them like have a better understanding of AI. Vision and language is the most direct modalities to go. You can talk about plans too, but probably it will be harder for people to understand. So talking about spreading and the information as wide as possible to the public. Remember, we are in a societal economical experiment. We are not alone. Everything you do, you influence the others' perception about AI, and they will generate new data to train the next round of the AI. So it's all connected.
Yeah, true, definitely. And what
And
are
that's why I appreciate your efforts to do the podcast. And you need to get to the wider audience groups, not just within the AI enthusiasts or AI researchers. You should talk to grandparents. Right? You
yeah,
should talk to. I mean, if the podcast being viewed by people from all kinds of occupations, that will have a much stronger societal impact.
yeah, and I think with the recent developments in, at least, I mean, I don't know if I should say thanks to ChatGPT or something, but it has brought the whole AI field at the outburst of like people who don't understand AI. I mean, I wouldn't say like that's a bad thing, but a lot of people have very wrong conceptions about AI, because either like people are very scared of AI, or people are very over optimistic about AI, because they think, oh, it's gonna rule and it's gonna change how we operate things, which somewhat is true. But I think the scary part of AI, like I think a lot of people have been claiming about how AGI is near the corner or something like that. Like even though we don't understand what exactly AGI is, like you said, it's an open definition, right? Like I'm open to say doing this thing can help me get AGI, but that's not the true one. So I think, yeah, I mean,
there is a lot of noises around there. Of course, any field when they get into the hotspot,
yeah,
right, spotlight, there will be a lot of noises, and I think that's also one of the responsibilities for AI researchers and the practitioners. Spare some of your time to dedicate on public education.
yeah,
I mean, it's just a mere effort to improve a little bit of the perception about AI, about the general public, may help the whole group to gain more support, to gain more understanding. And like I said, it's a dynamic system. Maybe one link goes wrong, it will lead to a never-ending, iterations leads to disaster. You never know, but just maybe try a little bit. That's why I like the podcast you are doing. This is great effort.
yeah,
And one of the things I was thinking, all the ChatGPT, GPT models, or the large models are using data that every single person from the society generating.
yeah,
Right, unless you are just 100% disconnected from the internet.
yeah,
You post, you make comments, you post videos, you do chat. Those data may ultimately get into the next round of models.
yeah,
That's why I believe a regional effort for us and for the whole community is promise to provide universal basic AI access to everyone. I call it UBAA, universal basic AI access to everyone. Because every single person provided data for you to train a model. So the least amount thing you can do is at least give people the basic access of the tools. And think about the following, just hypothetically this experiment. A kid grow up, like was born this year, grow up with access to ChatGPT compared to a kid has no access to ChatGPT. What will be the difference to them when they grow up?
yeah.
Like in 20 or 24 years.
Yeah, yeah,
And I would say it will be significant.
yeah,
So if well, you can pay for ChatGPT-4 and all that. That's all fine. It's all revenues.
yeah.
You need to make money, but the basic ones should get everyone access.
True.
And then at least every single person in the society get the basic amount of access to AI for their benefit, for their development, for their education, for all kinds of things. That will create a much more welcoming perception from the society as well.
Yeah.
I'm going to talk to a group of seniors. Actually, this is one of my efforts recently, is talking to the lifelong learning people about AI. Will be at the Tempe Public Library on October 19th. So I will learn something like what kind of perceptions people, especially our grandparents level, people think about it. And maybe we can further align. I would be happy to share with you all the learnings I have.
Yeah, definitely.
Talking about the two kids grow up, one with ChatGPT, one without ChatGPT, how different they are going to be, it can only be told 20 or 24 years later.
Yeah.
Right? So we never know.
Yeah, I mean, to add to that, I think that's what I think ChatGPT, like OpenAI did, right? Like I think they built a product out of it, and they kind of open sourced to use at least like to use it in a very responsible way. And I think it created a lot of havoc in very good and bad ways, but at least like giving it back. So I think some parts of ChatGPT are still usable to people, and some of it are, I think,
I
paid
think
versions.
as a community, we at least needs to give the public this image that we are not just closing it, right? So
Yeah.
if all the data is being contributed by everyone, then at least a basic access needs to be given to everyone for free. Right. I don't know how long ChatGPT 3.5 will still be free. I don't know. I mean, you never know. Nothing we can control about that.
Yeah, true. And let me switch case. Like I wouldn't say switch case, but like trying to understand in a much more technical sense. So this whole architecture of transformer that came out through large language models or in the field from NLP, but it has been existing, like you said, like the idea of attention in attention using neural networks using attention has been in the past. What to you is the unique thing about transformer architecture? That's my first of the questions, like why it has been so good at doing NLP related tasks, and secondly, how do you see that being applied to the vision? Because we have like vision transformers and everything. People have been publishing this stuff in a lot of domains. Like I have been following medical imaging tasks a lot. The results are not that much promising. We need still, I think, a lot of iterations on those versions. But do you think it is going to change or create a paradigm shift of like convolution based networks versus attention based models in vision?
Right. It's interesting you ask this question, right? So it reminds me the days when I was graduating from my PhD. I was also doing a lot of interviews, and at that time, the question will be, what do you think the uniqueness of CNNs compared to SVM, right? And I think the question I would like to put, of course, the answer to this is transformers is much more adaptive. There's the self-attention layers that opens up the context of the language, the sentence length, and the perception window will be much larger than the IBM word 4, like model 4, right? So 4 words for modeling. So that basically enabled its power for self-attention, enable its power for capabilities, as well as the parallel processing, right? So it could run much more efficiently. But I think the much more interesting question to ask, especially to ask people out of the graduate school or in the field, is what are the still not so performing well aspects of transformers, and how can we deal with them? That was the answer I give at that time, being asked, what is the uniqueness of CNNs? And I basically asked back to the interviewer, what is the not so uniquely good things about CNNs? The window size is not adaptive, cannot be parallelized, and all these factors that leads to transformers. I probably need to go back and who interviewed me. Maybe he leads to the whole publication of transformers at that time. But the whole point is the way of thinking for PhD students is not about all this are good. Okay, then you say, okay, this is good, this is good, this is good. They already exist. Right? And understanding this is good, and this aspect is good, that aspect is good, that aspect is good, helps you to deploy them. But in a more critical fashion is what are not going so well. And then you can innovate beyond that. Now, if you are asking me what are not so going so well with transformers, I don't know. If I know, I will innovate. Right? So apparently it's performing amazingly. Nowadays, like you mentioned, also in a lot of vision tasks, it's one of the dominating mechanism. But here's the twist. If you ask me, what is the biggest, like which innovation, like from classification to CNN, and from CNN to transformers, which gap is larger? Of course, the previous gap is larger. Right, from the way people think in statistical modeling SVM's way of doing classification to CNN way of doing end-to-end training of recognition. It's a paradigm shift.
Yeah.
From CNN to transformer, it's not a paradigm shift. It's it's a significant improvement.
Yeah.
Which I'm not saying, the improvement is not large enough, but it's not a paradigm shift.
True.
The previous one is a paradigm shift.
Yeah. So as in like transformer is more like an alternative to convolutions rather than a shift. And I mean, one thing I would like to add, like you said, like what are some of the things that maybe transformers are not really good at in terms of vision. One thing I can definitely say, and these are some of the findings from our group also, is in terms of at least medical images, and when you have like limited data sets, transformers don't tend to work really well. So it needs a lot of huge amount of data sets to understand the granularities in the image, if that's something of interest for the task over there.
Yeah, but one thing that also makes transformers models unique is its pretty amazing capability to do transfer learning.
True.
Right.
That's true.
So you can essentially the output can be adaptive to a new task.
Yeah.
But the backbone and all the previously trained features, you can easily adapt to a new task.
True.
Of course, I wouldn't be surprised that directly applying them onto a medical image data set, it's going to see some it needs a huge amount of medical data as well to do fine tuning.
Yeah, and I think that's why I think there's a lot of focus from people to build foundation models on different kind of medical imaging modalities. So let's say if you're working with MRI, they have like foundation models for brain imaging data sets, and people from NVIDIA who have like huge power to do that.
Yeah, sorry about cutting you.
Yeah, no problem.
But it's also always go back to the goal, right? If you are saying the ultimate goal the goal for your tool is to facilitating diagnosis of medical issues, it's a critical AI application.
Yeah.
So robustness and accuracy and fidelity matters a lot. You may not cannot suffer from one miss.
Yeah.
But if you say a chatbot to entertain people, the error bound could be very large, right? So depending on the application, the ultimate goal, the pathway would be different. Right.
True.
So the benefit of one backbone or the uniqueness of one mechanism may not translate so well to a different goal, right?
True. It's very subjective to evaluate. Yeah, like you said, like it depends on the task and what is the end goal for doing those.
Most of the AI big news or big applications that made into the public perception are either loosely or closely related to entertainment. Right. And the entertainment is the part that the general public accepts and take it very well, right? Chatbot, right? And old days, I don't know whether you were following Go Play, right? AlphaGo. Yeah, and then the IBM Watson Challenge.
Right.
All this entertainment. But very few AI has been proven to be robust and accurate and with high fidelity in critical challenges. A autonomous vehicle is one case, but you see all the news coming out from San Francisco, how people play with autonomous vehicles. And then if you go onto the any flight, right? Are they using AI to do flight control? I mean, you may be some amazed. No one is using neural network to do flight control.
Yeah.
But it's so straightforward.
True.
But it's just not to the point that can be directly used in critical tasks.
Yeah.
But I'm not saying entertainment is not important. It's important.
True.
It's a lot of applications that goes to be critical for the general public's interest. But the critical applications are still not yet being tackled. So just like medical imaging.
So let me ask you this question then in that case, because this would maybe try to maximize out of the research or academia is what would it take? So like we work with a lot of doctors and medical professionals, and the biggest critique that we tend to get is they are not sure how this thing performs, right? Like when you said about the earlier example, if a student comes to your lab saying that, oh, Professor Yang, I'm interested in deep learning, you have a modality or maybe a way of interrogating that person, right? Like you ask questions, you get a lot of perception about how he's answering. Is he's nervous, if he's saying the right things, wrong things? So you have a much more subjective way of evaluating if this person is a genuine enthusiast or how much his or her expertise is. But when it comes to AI models, it just predicts few values, but I'm not sure how it really relates to the actual neuropathology of a disease, or let's say for autonomous vehicles, like why it exactly did. So what would you say is the missing block that maybe as a community we need to work on, so that people who are not from AI domain, so let's say lawmaking, medical healthcare, autonomous like vehicle industry, can really be sure that, oh yeah, this is good, like I can use now AI? Because like I think there's one small missing block that I think maybe not a lot of people from academia focus on. Maybe people
I can
in
feel your
industry.
pain. Yeah, I can feel your pain. And as a matter of fact, I'm serving on a university level, ASU university level generative AI committee. And you know which school that has the most, trying to avoid and distance itself from generative AI? The law school.
Oh yeah.
Right. So all the case studies,
Yeah.
their students can just put them into ChatGPT, and ChatGPT gives you perfect case studies.
Yeah.
So they are facing challenge how to accept, how to analyze, how to actually live with the large language models. And of course, medical schools, such a rigorous training, 10 years of rigorous training. Now you're telling me AI can do similar things, right? I think the challenge is still general education. Right? If you have AI courses in elementary school, starting from just like you have math course and physics course in middle school and high school, then the time when you becomes a doctor, you have the basic understanding about fundamental stuffs with AI, and you have a much open mindset to accept or at least try out tools that being brought by you or others or developed by others.
Yeah.
So like I said, it takes time.
Yeah. True.
And that's something I really enjoy today's conversation, Jay. Yeah. I think we should make some kind of agreement. Maybe in 20, if I'm not like intruding too much of your personal privacy, like how old are you? Like
I'm 27.
27. I'm 36.
Okay.
Right. Well, very close.
Close.
I think what we should do is we should make an agreement in 24 years. Let's do another podcast.
Yeah. Yeah.
And I think in 24 years, we will see a generation of people that had basic education about AI starting from elementary school.
Yeah.
At that time, we may be able to see what the influence of all this effort we are doing that actually impact the society, and the society impact AI development as well.
True.
24, I will be 60. Hopefully, I'm still around within ASU or doing my professor job. And I'm not sure where are you going to end up, but maybe let's plan for a podcast in 24 years.
No, definitely. I mean, I would be super optimistic, because I think in the 24 years, it's a very long time for AI, because we have seen so much in the last 10 years. So I would be very amazed to see what AI can bring in the next 24 years, because it's more like a compounding effect, right? Like I think people have been multiplying on people's efforts very fast, and AI has been one of the very fast developing fields.
That's why it's an exciting time to be in this domain. And you will be 51, and I will be 60.
Hopefully, I'm
Oh,
yeah. Hopefully, I'm still much more in touch with research.
That's also an important thing to our students watching this, like balancing your life and work, right? Keep a healthy life, keep a happy life.
Yeah.
And there's a lot of things to enjoy. And maybe we could have a third one when I'm 84 and you will be 75.
Yeah,
right?
yeah.
Two old folks sitting here and talking about AI. And then we'll review what we did today.
Oh yeah.
That would be fascinating. Right?
It would be really great. It would be like a longitudinal study of like what AI used to be
and
how it has came to be. Yeah. But let me ask you even a much more broader question,
Mhm.
and this really interests me on a very personal level, is to trying to understand how do people like you get motivated for research. So what drives you for, like, let's say if there's a problem set that you're working on, we have fundings that we work on as a professor and in academia, what motivates you for research? Like, how do you pick a problem to work on? Is it the applied part of it? So let's say if you're working on autonomous, like, do you really like the part of like having autonomous vehicles around and the beauty of it, versus, oh, this is a very fundamental problem that I want to answer, and like I really like the math, the science behind it, and the whole AI field developing forward? What motivates you more?
Um, I think, well, first of all, this is a great question, right? So we all seek meanings, right? So what, like, the ultimate question human being ask ourselves, what's the purpose of what I'm doing, right? That's
Yeah.
the goal.
Yeah.
What's the goal? And if this is the ultimate dilemma for AI researchers, for example, if you're saying you believe that ultimately AI intelligence will surpassing human intelligence, then all the things you are doing right now should be able to address by the AI then, right?
Right.
So make all the things you are doing right now meaningless and pointless.
Yeah.
if you believe it's true, right? But I think the important thing is being able to realize that this exciting era we are living in, and this huge, gigantic societal economical experiment that never going to be launched previously, now is being launched and developing, and we can peek into it. We can observe it. We can study it. That's the exciting point. That's the motivation, right? So one argument I always trying to make is that's always I ask my fellow professors and researchers, if you have unlimited funding, what would you do? Right?
Yeah.
That's the ultimate question, right?
Right.
Of course, we don't. That's like a dream.
Yeah.
But let's be a bit more romantic. Right? If you have unlimited fundings and support, what would you do? Right? What I'm going to do is, and also if there's no, I mean, of course, there's a lot of ethical issues
Sure.
surrounding around all this experiment. But I think if we observing all this, and ultimately would like to collect so-called human being two,
Right.
just like the sphere 2. Have you ever visited Tucson? There is a biosphere 2 trying to replicate the biosphere. Biosphere 1 is the Earth.
Oh, I see. Okay. I
So
haven't been.
human being 2 should be the ultimate persona, that all the sensory data, perception data, language data, voice data, sound data are being captured starting from the first day till the end of a person's life, and being captured in a digital format. And
Wow.
this will be the data that you can imagine how large the data would be, just a single person.
Yeah.
Of course, there's all the ethical issues behind it.
Yeah.
I'm trying to, I'm fully aware of it.
Yeah.
But we're doing like imagined experiments, right?
Wow.
That will be the data. I mean, you were talking about ImageNet. ImageNet is just a tiny bit of all the vision data we are encountering.
True.
If you send ImageNet to out of Earth aliens, they look at the ImageNet and that data, will realize the human being never sleep, because 99% of the people on ImageNet data, they never sleep.
Yeah.
But it's not a good representation of all the digital sensory input we experience as a human being from the very beginning to the end, right? Are we going too far?
This is interesting. Yeah, this is interesting.
If you have unlimited resources to conduct, and you all have unlimited time to conduct, time will tell.
Yeah.
Whether training end-to-end model with this kind of comprehensive, holistic sensory data of a whole life of a human being, what leads to intelligence.
Mm-hmm.
And if you have multiple of this data, human persona 1, human persona 2, human persona 1,000, will that help to reach the next level of intelligence?
Yeah.
I don't know. I don't know. It's just a thought experiment.
Yeah, but let me follow up on one of the questions, and I'll act like you said, like we want to talk to people who are like the grandfather or someone who doesn't understand AI the way we do. And you started off by saying that the general hypothesis is that AI ultimately will the intelligence that we build, the artificial intelligence we build, will be able to surpass human intelligence at some point. And there are some set of people who would be worried about this thing. Why do we want to build a tool or a technique or a paradigm that can surpass human intelligence? What would your answer be to them? Like, why do we want to create a tool that can be smarter than us?
First of all, this is a hypothesis, right? This is a hypothesis. This is like a belief that justify the meaning of what we are doing.
Right.
Whether it will be true or not, still we are unsure about it.
True.
But it's just like when you are saying, hey, you build a vehicle that's running much faster than human beings, and then you're telling people, hey, why would you want to build a vehicle that's running much faster than human beings? The intelligence is just another level of a dimension of human capabilities, and we want the machinery to conquer. And another thing is, it will basically unlock the next industrial revolution, right?
True.
And ultimately leads to well, I can understand all the concerns about that. That's why we need to put AI into a cage.
True.
And another thing, this is also the ultimate pitch I want to make, is that's why we need AI researchers and scientists and practitioners who truly understand AI to be the AI leaders.
Right.
Have you heard about the story behind the Chernobyl, the disaster of the nuclear disaster?
Oh yeah, Chernobyl. Yeah. Yes.
So after the disaster happened, they start to think about consulting nuclear experts how to contain it.
True.
If AI, I mean, there's a lot of discussion about the author from the Homo sapiens. He is talking about there's exactly he is talking about all the potential AI disasters. But I think the important thing is, as a human society, we need to be aware that AI is such a potentially powerful and super powerful thing. We need wide amount of AI education and AI scientists, researchers to be always in the conversation of how they are being used and how they are going to be deployed to prevent a potential event if there is going to be there is anyway going to be one at the end. All right. So if I talk to the grandparent, I will say that the important thing is, rest assured, we need to have good amount of AI education and also create a coalition of researchers, scientists, public relationship maintainers, I'll call it, right? And this whole ecosystem of AI would work in a way that try its best to contain the powerful thing within its cage. Right, and that's what we hope, and which we should practice. This is also leads to all the enthusiastic people in AI and young people figure out a role in this local ecosystem. Not necessarily you need to be the person that comes up with, let's say, next transformers. You will contribute to AI, but we need all kinds of people, all kinds of roles in this ecosystem. Researchers, developers, implementations, public speakers, public relationship maintainers, all should get basic AI training and has a significant role in this overall ecosystem to make it robust and healthy. And if you feel, hey, I go and pursue my PhD, the first thing I ask every single PhD is figure out what's your capability, right? Are you good at math or programming or speaking or in public? And you'll find your role in AI ultimately. And that's why it's so exciting to pursue AI career nowadays.
Yeah. And no, I think one thing you did mention is very, very apt, and I think that people need to focus more on is understanding the strengths and limitations of any tool that comes out nowadays, and especially in the field of AI, because it becomes very easy to have a certain set of benchmark and like we can say that this model performs really well, but how much does it really mean? Like we need to understand what are the criticalities, and especially when we are dealing with these kind of big models, it becomes a whole set of field to just to understand how much this model can perform in certain set of domains, like for example ChatGPT, like how, if I'm going to use it in the most wildest way, how people are going to react to it, like people who have different set of educations, different set of backgrounds, different set of expertise levels, how they are going to operate. And I think it's happening. It's happening. A lot of people are trying to do this, and this is going to lead a long way.
That's why I'm saying it's an exciting time to still join and work on AI. Both NLP and CV are not saturating. Actually, because of all the development, we have breakthroughs and a burst of new opportunities. And every single tiny bit of opportunities may make your career, right? So exciting time.
So let me ask you this question. Even though I like to call myself a CV researcher, let me ask you this question, that first of all, I would take this in a two-part way. So you said like there are a lot of challenges that are still open in vision, but in the last few years, I would say like a lot of people have been focusing on NLP research a lot in terms of number of throughput of papers and how developments are being made. First of all, the first question is, why do you feel CV is not saturated? And this ties to the second question is, what what challenges do you think are still very open and very fundamental that people as a community we need to work on, at least in terms of vision?
Well, one thing that we are focusing on right now and also trying to explore is how, again, use language modeling and semantic modeling, this vast amount of models that we trained using the vast amount of digital data, can they help with low-level vision tasks? I mean, this is very intuitive. For human beings, our semantic knowledge guide us to do better in our low-level vision tasks, such as that depth estimation, such as ordering, such as structural design and motion 3D modeling, right? But nowadays, the pathway is still one direction, right? From signal to structure to understanding, then to reasoning. What's the pathway back, right? Can we create a pathway back to show that foundational models has a significant role to help unlock next round of low-level vision understanding, and that will improve the perception performance, and that will improve the recognition performance, that will improve the next round of semantic models trained from vision domains, that you'll basically be able to create a closed loop to bootstrapping the performance of every single submodules. That's one direction I can see, but of course, it's not so obvious how people can do it. Again, the mere fact of the LMMs coming out creates all the possible research direction, like you mentioned, that people are dealing with LLMs, right? Now you have this in a scientific experiment fashion is basically the observation target, right? The focus of the experiment. And then there's all kinds of ways you could come up with to observe, to query, to get feedback, to peek into it, to think about what will be the next evolution streamings of data to improve it. Right, all this are becoming possible. Also, another thing is use this for applications like medical imaging domains, transportations, education, right? All that aspects being traditionally done in a one way. Now you have a way to modernizing it. So that opens up all the possibilities.
True.
So it's not saturating in any sense.
Yeah.
And I wouldn't be surprised that computer vision NLP fields will continue growing.
Yeah.
And it will be basically end up in a very general subject as physics.
Yeah, true. I mean, definitely, I second that. Working in this field for like 3 years or maybe 4 years, I would say, I feel the same thing. But the reason I asked this question is like I recently had a student who is a friend of mine at master student over here, and he wanted to convert to PhD. And a very naive question, he asked me like, which area of AI I should be focused on? And I said like it depends, like what kind of projects you want to do and what interests you. And he said, oh, I think with the chat GPT, like next 10 years, people would be much more focused on NLP, and hence I maybe should pick an advisor or a project that is working on NLP. And I said no. And then he said like, oh, I feel the vision has been saturated because we don't see any big developments. And that's the reason, like I think when it comes down, the last point you made is very, very apt, is when we try to use these models in actual applied domains, when it comes to like, yes, I have a model that can learn patterns in a very nice structured way, but when I apply it to, let's say, autonomous driving, when I apply it to like you said, like low data sets or like low level vision, the challenge is try to emerge very quickly. And that's when I think people have secondary contributions building on top of what we already have in vision. So yeah, it's far away from being saturated, at least in vision.
Also, we could look at this problem that your friend raised from a perspective that we are in a large societal economical experiment.
Yeah.
Why? Because of all the automation and intelligence, that the society is being able to produce enough supplies to us, that more and more people becomes with the privilege to do research. Yeah. I mean, you can imagine like if we are a tribe living on a small island, 100 people. 99 people is breaking coconuts. Yeah. There's one guy wandering around the island and trying to figure out how to escape the island. Right. That's the one guy that the society can afford. Now with the revolutionized productivity and with AI around the corner and all the tools coming out, higher percentage of the society, the population, has the privilege to do research, and doing research is a luxury, right? Yeah. I mean, of course, at the end of the day, you will say, okay, I got my PhD, it enables me to my next career steps. But the mere fact of doing a research that disconnect you from maybe flipping burgers or doing paralegal things. True. It's a privilege. It's a luxury. And this whole training of gaining a PhD, at the end of the day, may not be topic relevant.
True.
I mean, the just like playing sports, so many people playing sports. How many of them made it into NBA? Yeah. Right. But the way that you got trained to how to deal with rejections, how to deal with public perceptions, how to present your idea well to the general public, as to your colleagues, to your peers. This capability stays regardless of the topic you choose. Yeah. And that's why I'm thinking a PhD ultimately. That's why we should talk in 24 years or 48 years. Yeah. I would think 5 years PhD training might become a very common thing for the general public in the long run. It's actually a very, very obvious the trend is, right? You get out of your undergrads, and then all the jobs are being automated. What are you going to do? Like you can get a universal basic income like Yezhou Yang mentioned to you, right? So and then enjoy life, and what would you do, right? The meaningful thing is pursue a PhD.
Yeah, could be.
Of course, there's a lot of financial issues and other stress nowadays. Pursuing a PhD is still associated with it. But this is why we are living in a societal economical experiment. The research that you do affecting the overall system, affecting why you are doing PhD. And having this kind of understanding may better justify your meaning, why you are doing collecting data or writing papers. One of the things I always mention to my students, during my third and fourth year of PhD, I got 7 consecutive rejections.
Oh, wow.
And that was the time I was struggling, learn how to deal with difficult situations, right? Dealing with how to improve. And that trained me, a really good fortune of on capabilities that I'm, nowadays feel, the rejection is life. Right? Acceptance is a privilege, is a luxury. You should have a right attitudes towards rejection and criticisms and public perception, peer perceptions about your research, and that all that comes with by having PhD training, and it's topic irrelevant.
And let me ask you a related question, because you said because you had a lot of rejections, and this is a very, very common thing in AI, which is, I think, a good and a bad thing at the same time. Is a lot of people have been interested. Like, we have more and more people coming into the field of AI research, publishing work, but we also see a lot of noise. So when we in terms of like when I got started in the field of computer vision, I was trying to understand what are the benchmarks, what are the baselines, where do I start from learning any basic kind of computational imaging analysis. We have a lot of good papers which are fantastic, but we also have a lot of papers I wouldn't say that I would recommend anyone to read when you are getting started. It's fair to read those papers maybe just for fun on a Sunday afternoon. How do you yourself keep yourself updated to good papers that can maybe challenge you intellectually to maybe have some new perspective on your research versus something that's like a good paper to read?
May I just say that that's a secret sauce that I wouldn't want to share?
Can you please share?
I would say, I mean, the interesting thing about this is, first of all, like, come back to the about rejection, right? The writing papers and doing in PhD training and all you write papers, you present, you got peer critics. This is the low risk, low cost way of train yourself. Imagine you get into a company, and then the company pouring resources on your project, and ultimately it didn't go well. That's going to be much more costly, right? So if you want to learn how to deal with this whole cycle of innovate, write up, present, get feedback, re-innovate, getting PhD training and getting yourself submit feedback, accept, oh hooray, not accept, it's fine, right? It's the easiest way to get trained, right? Low cost. What's the cost? Like, are you going to get fired? I mean, but when you are saying, how to get most update to that, I like the way you are thinking. Actually, this is the question I typically ask to the students who would like to have an interview with me. I mean, I would like to do PhD with you, and what are you going to ask them? Maybe I shouldn't talk about it, because if I talk about it, like the follow up,
have the answer sheet.
Exactly. But I think it's fair. I would typically will ask, in Mandarin we call it 名不副实, but if we have Mandarin listeners, they may understand. What I'm basically asking the candidate will be, over the years, of the recent years, all the papers you are reading, are there any paper you think their claimed contribution not match up the hype surrounding it, right? So if you are an active researcher and you are thinking, you have your perception, you have your own judgment, and you will be able to name a few of this paper, just like what you were saying, right? So this paper is none worse to read. And by doing that, you'll be able to understand what are actually missing
Right.
beyond the hype, right? And then that leads to the next work, research you could potentially contribute to the field.
Yeah.
And that's always the question you ask yourself, right? So now I read this paper, it's got, populated around the internet for days. Everyone was talking about it. Then the question you ask yourself is it actually up to and match the hype around it?
Yeah.
It could be not. If it's not, why?
Yeah.
And then that leads you to good thinking and good discussion as well.
And this is very similar to one of the tweets. I forgot who was the professor. Like he was, I think, from CMU, who tweeted that we should have awards in conferences, something called test of time. Right? So like instead of giving awards, like we have awards for every batch of submissions that we have at ICML, NeurIPS and all those kind of conferences, but they said like to have introduced one category of test of time. So meaning it would include papers that maybe are published 5 years back, but it has sustained its
surprising, ICCV is doing that already. So there's called the Mars Award, and there's basically a paper after 20 years got being nominated for such award to show that they are actually being practiced and being used. Yes,
we should see that more often, I think, and that's like maybe a training process for people who are doing the graduate study. Like once you read those kind of papers more, you try to understand and maybe subtly pick up things from reading a paper.
Everything you do, that's what my advisor, another co-advisor, telling me. Everything you do in academia and doing writing papers, submit, get rejected, or get improvement, or get accepted. And then you basically, I mean, another interesting thing is we were trained to be happy with more work. If you got accepted, you need to prepare the talk, you need to travel, you need to. Then everyone is, hey, I'm happy, I need to do more work. But my point is, all of them, as two young people, enjoy every single moment. Enjoy the feeling of being rejected. Enjoy the feeling of being criticized. Enjoy the feeling of we would like to eager to present. And all of them are practice, like improving you into a better person.
Yeah, true. And I think most of the times feedbacks, at least we submit to a lot of journals, and most of the feedback I get are like fantastic. I mean, I have never, at least except for one instance, I've never received feedback that was something I would feel frustrated about. Like these are like people who are senior in their field and they critique and they actually make your paper look good, right? Like people like for
it's
journals.
A practice.
And
it's a practice.
Yeah, and it adds to the readability factor a little bit more. People who read and they learn something new, and that's
exactly it's a practice, and that leads to everyone's efforts to maintain the ecosystem a positive and energetic ecosystem. Do your service for reviewing the conferences, contribute your intelligence to others while receiving others' intelligence as well. That make the whole ecosystem upward, right? That's why you got good feedbacks and you feel better and your practice getting better used, and then you'll feed back to the ecosystem, getting others to get better practice. So as the AI researchers as a group, we should grow together and have a much stronger impact over the outside world, not just within us. Within us, if the ecosystem is going bad, then that's when a field start to die. And we've witnessed a few of such cases, right? I'm not going to name any specific field, but if ecosystem, if the dynamics is going down, then that whole field will facing challenges, and then their impact will be shrinking until no one cares about that field. Right. So maintaining a good, dynamic, upward, positive, and I know all the noises, all the stress nowadays PhD students are getting, but understand that everyone is practicing within this ecosystem. We are practicing getting better together, right? So that's also what I tell my students in a group. A group is where you basically help each other. APG, Active Perception Group, we also call it Assist Per Game. we measure not about how much points you make at the end, it's how much about your assists that you offering to others as well. Then you create a much positive group with positive kind of vibe.
Attitude.
Good things happen. That's why I like your podcast.
Well, thanks a lot. And maybe this might be one of the last questions that I normally try to end the podcast with. And since you are a person like you mentor a lot of students, you teach a lot of students, and have been in the field for a long time. And since
not that long,
I mean, but still, you have been, at least you have been in the vision research before 2012. So I think for us, like nowadays, the field progress is so fast. So anyone who has been in this field consistently for more than 10 years is like a long time. It's like the world is revolving faster for people in AI. And you get a lot of people reach out to you trying to join your lab, or people who are interested in AI. What kind of message would you give? Because some of the people, even though they might be swayed into the idea of like they are interested in AI, maybe AI is not something that they truly like doing as a full-time work or full-time research. What kind of litmus test would you give to those people to try to understand their interest in AI better? So if a person comes to you, oh, I'm interested in AI, Professor Yang, I want to work with you, but how do I personally evaluate if I'm truly interested in AI?
That boils down to the ultimate philosophical challenge to every single person, right? Know yourself. Right. You need to be self-aware. What is your capabilities? What is your advantage? What's your disadvantage? Like I mentioned, math, programming, presentation. Right. Let's say there's 3 dimensions. What is your chart? Are you super good at math? Fundamental research should be the things you pursue, contributing fundamentally to the field. If you're good at programming, practical research, right? Creating packages, creating open source softwares to contribute to the community. If you are super self-organized, well-organized, creating data set, right? That takes a lot of patient efforts, and not every single person can achieve that, right? If you are good at presentation like you, create a podcast, right? Influence the overall community, influence the public perception about our team and our ecosystem. Every single person, based on their own understanding about their self. Of course, you need to have a good understanding of yourself, right? If you truly not good at math and you're claiming, hey, I'm a math genius, you'll suffer, right? If you are truly not good at implementation and you're saying, hey, I implement everything like a charm, no one will going to use your open source software, right? So first know yourself, and then figure out. I will try to suggest a pathway for the student join my group based on your capabilities. And at the same time help others, right? If you're truly good at math, some of your lab mates be good use of your talents, right? Then create a good collaboration environment. And some of the PhD students are great at making figures. Well, they are just like an artist, right? So make good use of your own talents and find your role in this large ecosystem and enjoy it. That's my message to the student.
Yeah, that's very interesting. I mean, understanding what your core competencies are and like living ahead and trying to develop more on top of it rather than trying to win it all.
And also, pursuing a PhDs to improving other capabilities, right? So you can have a much more balanced basket of capabilities.
And let me ask you one selfish question over here towards the end.
How selfish is that?
Like how do you define a good research problem? Because most of the lab students in your lab are like PhD students, and we have fantastic ideas. We read people publish work on AI, and that's very motivating. But at the same time, we try to understand like what makes a good research problem. And
so if one sentence, if you end up achieving anything with respect to that research problem, you have inner eagerness and motivation to present it to others. That's a good research problem.
Okay, that's interesting.
You should be proud and eager to present what you achieved to others, and that's the ultimate. In ancient times, we call it simulus, right? A good research problem should incur the most amount of simulus among people. Simulus meaning eager to get recognized, eager to get public acceptance, or from the peers or from the general public. If a research topic you're working on, assuming you get something at the end, and assuming you made a publication, a workshop, conference, whichever, you'll be happy and eager to. You cannot wait to go and talk to people this exciting things you did.
Yeah.
That's a good research topic. If you're working on a research topic, you achieve awesome performance, and when you are going to go and present, you feel like, hey, no, not something I think people will be interested, or I will be proud to present. Then that's not a good research problem to you.
I see. So as in like understanding your internal motivation for working on those problems would be like the biggest factor.
Ultimately, I think the PhD training is to cultivate your eagerness to present to others, to peers, to your colleagues, to the general public what you achieved, and this is the ultimate driving force to pursue a good PhD. Right? Shouldn't be from your supervisor, shouldn't be from the stress outside, shouldn't be from, I need X amount of publications to get a job. Yeah. The inner motivation is, I would like to talk about my research to others. Yeah. And I just cannot wait to talk about it. That's why I need all the results, all the performances to make the story, and I want to present to others. Yeah. Yeah. Then you'll enjoy the whole process.
Interesting. Yeah, that's a nice outlook. I definitely
and
would
ultimately, even you do an interview, anywhere you do an interview, you basically being bounded to talk about what you achieved, right? Yeah. So you should, if you don't enjoy about talking about your own work, then you'll be suffering. Yeah, right.
And interacting with a lot of young students over the time, what kind of things you would say are like something you would recommend not to have in your student attitude when you're working in AI research? Like, do you see any pitfalls that people can avoid? Like, don't try to do this kind of hints. Like it will.
My point might be outdated, right? So, cause the field is progressing so fast, right? I wouldn't like if 3-4 years ago, I wouldn't recommend students to tune into arXiv every day, because you got distracted. Yeah. But now the field is progressing so fast. If you are not getting yourself up to date, you may get easily, out of the frontier, right? Yeah. So all the points are dynamic. There's no golden rules, and explore. There might be a way that fits you best. And I think the ultimate, the critical capability is to be critical, yeah. Right? Every 100 people talking to you, you should do this, you should do that, you should do this. You need to make your own judgment. Yeah. If even I tell you, this should be the right way, this you should avoid, may not be true, right? May not be true to your case, may not be true to your age, may not be true to your field. Right, but I think one of the pitfall that I typically observe is students getting to PhD not yet determined whether you go with an academic job or industrial job. Yeah. I would think if you have set your goal as early as possible, that will make your journey much easier. Right, if you are targeting an industrial career, you should do a lot of things that are designed to have a fantastic industrial career. Yeah. If you are targeting to have an academic career, and there is another set of things you could do early to pursue. So if the worst case is you jump in between them, not determined, then it's not good. It's truly going to delay the whole progress.
Yeah, so it's basically like getting an understanding of what really interests you and drives you in your.
But that's the
AI
challenging
career.
Question, right?
Yeah.
So it's super challenging. Know yourself. That's Asian Greek kind of always applies.
Yeah, true.
It's the most challenging thing. Thank you so much,
But yeah, with that,
Jay.
thanks a lot. I think we covered a lot of nice topics, and in general, people who might want to get a brief understanding of how the vision field and has been emerging, and in specific to how it has been at the intersection of language. And I'll be leaving links to your works and your lab in the show notes, so people who are interested can check out. And I think you have some fantastic tweets also, so I'll leave your Twitter handle in the description.
Thank you.
But apart from that, thanks a lot for being here.
We'll chat in 24 years.
Yeah. I'll put a calendar invite for 24 years.
Thank you.
So yeah, thanks a lot.